Hi, Algebra 1. We are going to be looking at factoring strategies today and moving on to a new one called the DOTS, or the difference of two squares. So let's go back over the factoring strategies that we have already looked at. We're going to look for the greatest common factor to take out every time, and we're going to look for it first. Secondly, if a polynomial has 4 or more terms, we are going to try to factor by grouping. Next, we've looked at guessing and checking. And remember, it's guess and check. Both need to happen. Then today, DOTS, or the difference of two squares. So let's look at these words. Let's think about what they mean. First of all, to find a difference, to get a difference, you get a difference when you subtract. So that's a big idea we want to take away from today. To get a difference, you have to subtract. Of course, the difference of 2, these are only going to be binomial expressions. So the difference of two squares. Squares are perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81. All of those numbers are perfect squares. So you need to be familiar with them so you know one when you see one. So, where does the difference of two squares come from? Well, we're going to try these warm-up problems. So, hit pause, and then when you're done using the FOIL method, to simplify these warm-up problems, hit play once again so we can check. So let's start with number 1. If we're using the FOIL method here, remember FOIL method, first sides, outsides, insides, last sides. So first sides, x times x, x squared. Outsides, plus 7x. Insides, negative 7x. And last sides, negative 49. Now, something magical happens when we are getting difference of two squares. The middle terms are going to cancel out when we multiply these special binomials together. 7x minus 7x cancels and goes to 0. So we end up with x squared minus 49, which is the DOTS, the difference of two squares, the difference of two perfect squares. Yes, x squared is a perfect square, 49 is a perfect square. Next, 10 plus a times 10 minus a. Again, use the FOIL method. First sides, 10 times 10 is 100. Outsides, 10 times negative a, negative 10a. Insides, plus 10a, and last sides, a times negative a is negative a squared. Again, the middle terms cancel when we combine like terms, leaving us 100 minus a squared. This is the difference of two perfect squares. That's the DOTS again. Number 3, 5x plus 3 times 5x minus 3. First sides, 5x times 5x is 25x. Outsides, 5x times negative 3, negative 15x. Insides, 3 times 5x plus 15x minus 3 times 3, 9. Middle terms cancel, 25x squared minus 9. That is the difference of two perfect squares. Number 4, remember our properties of exponents here. 6a to the third minus 7b times 6a to the third plus 7b. First sides, remember to add those exponents. 6 times 6 is 36, a to the third times a to the third is a to the sixth. Outsides, plus 42, a to the third b. Insides, minus 42, a to the third b. Last sides, minus 49b squared. Remember, that's b to the first times b to the first, that's b squared. Middle terms cancel. 36a to the sixth minus 49b squared. That's the difference of two squares. So hopefully you're catching on very quickly to where these DOTS's come from. Here's one last one, number 5. This time I'm totally going to do it with the shortcut, knowing that the outers and the inners are going to cancel. If we know that we're going to get the difference of two squares, all we have to do are first sides and last sides. 9xy squared times 9xy squared is 81. X squared, remember that's x to the first and x to the first. And then y squared times y squared is y to the fourth. Minus 8 times 8 is 64. Z to the fourth times z to the fourth. 4 plus 4 is 8. Knowing that those middle terms are going to cancel every time, it allows you just to do first sides and last sides when we have this very special situation. So let's take a little bit closer look at this investigation. So considering our first warm-up problem, x minus 7 times x plus 7, that's what gave us x squared minus 49. So again, they're both binomials. They have exactly the same terms, x7, x7, in exactly the same order, x7, x7, except one's a plus and one's a minus. The order not important. Now, if they're both binomials with the same terms in the same order, one's a plus and one's a minus, these binomials are called conjugates. Conjugates. They are conjugate expressions. C-O-N-J-U-G-A-T-E-S. That is a big idea for the day. Be sure to write that down. Conjugates. When we multiply conjugates together, we get the difference of two squares every single time. So once again, the key to factoring DOTS binomials is knowing perfect squares. So let's fill them in here. How about hit pause, take a second, and fill in these blanks. So give a quick check. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared 49, 8 squared 64, 9 squared is 81, a squared is a squared. 5x squared squared, remember everything inside is getting raised to the second power, will be 25x to the fourth. Next, 10s squared t cubed. 10 is getting squared. That's 100. S squared is getting squared. 2 times 2, power to power, that's s to the fourth. And the t cubed is also getting squared. That's t to the sixth. We can make a quick generalization here. All even powers, not even numbers, but even powers, are perfect squares. So keep that in mind. All even powers are going to be perfect squares. Power to power, we multiply. That's what makes a perfect square. So let's do some factoring together here. So all of these now, we're given the difference of two squares and we need to factor. In order to do that, we need to recognize that we actually have perfect squares and they are in a difference. So first of all, what is the square root of x squared? The square root of x squared is x. And is it a difference? Yes. Check. Next, what's the square root of 36? The square root of 36 is 6. Why? Because 36 is a perfect square. So what are the factors of x squared minus 36? They are the conjugate expressions of the square roots. X minus 6, x plus 6. That's our guess. Now we're guessing very intelligently here because we know that both of those are perfect squares. We know that it's a difference. Therefore, we know that that is a DOTS. We can give it a quick check. First sides, outsides, insides, last sides, middle terms cancel. We're left with x squared minus 36. Those are indeed the factors. So let's speed up the process here because we are dealing with difference of squares here. We know they are difference of squares. Number 2, what is the square root of 4x squared? The square root of 4 is 2. The square root of x squared is x. So the square root of 4x squared is 2x. What is the square root of 81? The square root of 81 is 9. We are going to make conjugate expressions out of those square roots. So 2x minus 9, 2x plus 9. 2x minus 9, 2x plus 9 are the conjugate factors of 4x squared minus 81. Let's do it again. Number 3, is it a difference? Yes. Is it the difference of two perfect squares? Yes. What is the square root of 25a squared? The square root of 25a squared is 5a. What is the square root of b squared? The square root of b squared is b. We're going to make conjugate expressions out of the square root of both of the numbers. So 5a minus b, 5a plus b. We can give it a quick check. 5a times 5a, 25a squared, 5a times b plus 5ab, negative b times 5a, negative 5ab, negative b times b, minus b squared. Middle terms cancel. Those are our factors. So that's 1, that's 2, that's 3. Let's do 4, 5, and 6, and then we're done. We'll move quickly. What is the square root of 9x to the 4th? The square root of 9 is 3. And the square root of x to the 4th, remember, all we have to do are divide the index into the exponent. 4 divided by 2 is 2. The square root of 9x to the 4th is 3x squared. The square root of 64y squared is 8y. So our factors of this difference of two squares, 3x squared plus 8y, 3x squared minus 8y. Remember, it doesn't matter what you put first, the plus or the minus. Just one has to be present. They need to be alternating signs. That's number 4. Number 5, 100 m to the 6th minus n to the 10th. The square root of 100 m to the 6th. The square root of 100 is 10. The square root of m to the 6th, 2 goes into 6, 3 times. So the square root of 100 m to the 6th is 10 m to the 3rd. The square root of n to the 10th is n to the 5th. 2 goes into 10 5 times. The factors, 10m cubed plus n to the 5th, 10m cubed minus n to the 5th. Conjugate factors made out of the square roots of both of the terms. One last quick problem, reminding you once again what we wrote already. All even exponents make perfect squares. So what's the square root of 121 p to the 10th? Well, the square root of 121 is 11. The square root of p to the 10th, 2 goes into 10, 5 times. And lastly, the square root of 1. Something very simple. What times itself equals 1? 1. The square root of 1 is 1. So our factors here for number 6, 11p to the 5th minus 1, 11p to the 5th plus 1. That, ladies and gentlemen, is a complete explanation of the difference of two squares.